Hey there, and welcome to exercise number 93. If you want to solve this one on your own, then click on the link in the description. If not, keep watching and we're going to solve it together. In this one, we need to write a function named maxInvocations that will be used to extend the function prototype. The function should receive a number as an argument, let's call it count, and return a new function with the same signature and functionality as the original one. And here, by original function, I mean the function on which we're calling maxInvocations. Because remember, maxInvocations is on the function prototype, so we're going to call it on another function. Now, this function that we're going to return, so the one with the same signature and functionality as the original one, can only be invoked count times. After the limit is reached, any subsequent invocations, so any invocations after the count ones, should do nothing and have no side effects. So basically, let's say count is 2, we can call this function 2 times, but then if we call it a third time, a fourth time, and so on, those invocations won't do anything. Below we have an example, so let's look at that. We take the maxInvocations functions, the one that we need to write, and we assign it on the function prototype. Then we have an example function called printSum that takes two numbers and console logs their sum. Moving on, we're going to call maxInvocations on this printSum function and we're going to pass it number 2. And this one, this call will return us another function we're going to call limited printSum. Now we're going to call it once with 1 and 2 and it's going to print 3. We're going to call it a second time with 11 and 12 and it's going to print 23. Then when we call it a third time with 100 and 200, it won't do anything because we already called it 2 times and 2 is this parameter here. Then we call it again with 150 and 150 and again it does nothing. And all of this explanation that I told you here is written in the comment here as well. Now that we've read the description, let's go here into the right side, into the code area and solve it. Now the first thing I want to do is actually return a function with the same signature and functionality as the original one. So I want to handle this part right here. So let's just call this one const limited function is a function that's going to get, well, I don't know how many parameters because it depends on the function we're going to use it on. So I'm going to use the REST syntax to have unlimited parameters. And here we want to call again the original function. But how do we get it? And again, in this scenario, as in the previous exercise, the original function is actually this, because we're going to call this on the function prototype. So if I do this and here I spread the parameters, right, I'm actually going to call the original function. And if I do a return here, then we're going to have the exact same functionality. So if that function returns a number, this one will also return the same number. And also don't forget to return the limited function. So now let's test it so far, right? We didn't implement the count part. We just have a function that behaves just as the original one. So let me just copy the code, all of this one from here, and let's look in the console, right? So we get 23, and then we get 300 2 times. So it works as expected. Now let's implement the count part. And for this, I'm going to create here a variable called invocations left, which initially is going to be equal with count. Now here inside the function, we're actually going to need to check, hey, do we have some invocations left? Because if we don't, well, then we're not going to do anything. So I'm going to do if invocations left is equal with 0, I'm just going to return. And below, very important, I'm going to do invocations left minus minus, right? And right now we can see that the console log, the logs here have changed and we have just 3 and 23. So we don't have the number 300 printed twice. Why? Because each time we call this function, we decrement the invocations left, so we decrease this by 1. And when it reaches 0, we say, okay, this is 0 now, we're not going to do anything no matter how many times you call this function. So by the magic of closures, because we have a closure here on this variable, we have a function that we can only call for count number of times. Now let's test our solution, and voila, it works. Cheers and see you in the next one.